Hello, welcome to polynomial division. Today we're going to focus on one thing, and that is dividing polynomials. Here I have two polynomials, a really long one on the top and a little one on the bottom. The first thing I'm going to do is verify all the terms are going from the highest exponent down to the constant term. We have that in this situation. So we have an x to the fourth, an x cubed, an x squared, an x, and one without. So we're good and set to go. If we were missing one, we would insert a term in there, and we will look at that on a different problem. The next thing we're going to do is make a Polydoku box or an area model. The number of rows will always be 3. So there's 1, 2, 3 rows. They will always be 3. The number of columns will come from the number of terms in the top. So I have 1, 2, 3, 4, 5 terms in the top of my division problem. So I will have 5 columns. 1, 2, 3, 4, 5. This bottom part of my division problem, or the divisor, goes on the left. So 3x minus 2 is on the left. It will always take the middle and bottom row. This top row will be empty. The top of my division problem will go down at the bottom, and basically each term is going underneath one of the columns. Okay, the next thing we're going to do is start filling in the Polydoku box. And we start by placing the 6x to the fourth, or the first term down here, in this middle row in the first empty column. This will always take place like this. So whoever's in the front here is going to go right here in the first empty column next to the whatever was on the left here. So that will always be like that. After that, we have to calculate the top here, and it's a multiplication box really. So something up here times 3x was 6x to the fourth. So this should be 2x cubed. There it is, because 2 times 3 is 6, x cubed times x is x to the fourth. After that, I'm going to calculate the bottom row now. So now I'm going to take this top row times the bottom one on the left. 2 times negative 2 is negative 4, and then x cubed. The next thing I'm going to do is calculate the middle spot for the next column. So I'm going back over here trying to figure out what was right here. This one plus the negative 4x cubed is supposed to be negative 7x cubed. So the one that's right here plus the one next door on a diagonal is supposed to be negative 7x cubed. So we need negative 3x cubed there. That's why they put that. Negative 3 plus negative 4 is negative 7. Then I'm going to continue to toggle between the to the top and then the bottom, back to the middle, top, bottom, middle, and it's just going to keep going like that. So here I am again trying to figure out what times 3x was negative 3x squared. I mean, negative 3x to the cubed, and that'll be negative x squared. So negative times 3 is negative 3, x squared times x is x cubed. So now I'm going to take this top one here times the negative 2. Negative times negative is a positive, and then 2x squared, so that's what should pop up right here, and it does. Now we need to figure out who's in the middle over here. So again, something plus 2x squared is 11x squared. It goes in a diagonal, so 2x squared plus, this should be 9x squared, and sure enough it is. Now I need to figure out the top again, so I'm just going to keep toggling back and forth. So something times 3x is 9x squared. That should be 3x up here. So 3x times 3x is 9x squared. Then I take the top times the negative 2. So 3x times negative 2 is negative 6x. We were looking for negative 9x. So this should be negative 3x over here. Something times 3x is negative 3x. That should be negative 1. And negative 1 times negative 2 is 2. There they are. And these two match. That's really nice when they match. We have to do something different when they don't match, and we will look at that later. So to finish this up here, where's the answer? So here's my original problem, this big long thing divided by 3x minus 2. The answer is sitting in the top row. So if I divide these two polynomials, I get 2x cubed minus x squared plus 3x minus 1.